So consider the surface z equals x squared plus xy plus 3y squared at the point 115. I want to graph the surface and the tangent plane at the point given, which is this point right there. And I'll produce two different prints of the graphs. The first being a reasonable perspective to see both the surface and the tangent plane. The second after zooming into the point that the surface is, or such that the surface is indistinguishable from the tangent plane. Actually, we'll play with that a little bit, but I'm not going to go too crazy on the zooming in thing. I'll let you play with that. Okay, so I need a point, which I have, 115, and I need a normal vector, which I can use the gradient vector. So I need a partial with respect to x, which is going to be 2x plus y. I need to evaluate this at the xy coordinates, which is 1, 1. That gives me 3. And I need the partial with respect to y, which will give me x plus 6y, evaluated again at 1, 1. And that will give me 7. Okay, so I'm going to write this as, I'm going to think of this in terms of z minus z naught equals the partial of x, partial of y, dot x minus x naught, y minus y naught. So now I'm going to just simply substitute in these values. I'll get z minus z naught is 5 equals 3, 7 dot x minus 1, y minus 1. That's it. And go ahead and do the dot product. I'll get z minus 5 equals 3x minus 3 plus 7y minus 7. So I'll get z equals 3x plus 7y. This is negative 10 plus 5 is minus 5. So this is the equation of my plane. So let's go ahead and take a look at it. Here's some Mathematica code that I used to generate it. And here's the surface and the plane together. So I know the arrow is kind of huge. I need to figure that one out. I'm not too sure on that. But anyway, here's my surface. Here's the plane. This is a position vector pointing to that point that was given to us as 115. And I think you can see that's pretty reasonable to believe that that plane really is tangent at that point. And I'm not going to mess around zooming in. I mean, you can zoom in on this and kind of go crazy with it, play with it a little bit. Something for you to do. It'd be a really good exercise for you to play with, to zoom in so that you can see or convince yourself that the tangent plane really is a good estimation for the linearization process to estimate the value of the surface near this point of intersection.